Came Perak, the eldest of 7 children. His mother, Ph.D. binti Hassan, who had single-handedly brought them up since 1965, recently passed away on the 1st of December 2010. May her soul rest in peace. He has proven his leadership since his schooling days, being the head boy in the primary school and a prefect in the secondary school until he finished his MCE with a grade 1. After spending some time at the Malay College, he then joined ITM and graduated as the second best student and was awarded the Young Lecturers Scheme to continue his study for the Advanced Diploma in Civil Engineering and became a faculty member in 1980. After confirmation, Dr. Ruslan then proceeded to Syracuse University, New York for the Master of Science degree in Environmental Engineering and graduated in 1984. Upon his return, Professor Ruslan embarked on training to become a professional engineer by working as a resident engineer, as well as progressing well in his academic career as a lecturer, senior lecturer, and associate professor. In 1991, Dr. Ruslan was honored with the British High Commissioner's Award, enabling him to be the Honorary Research Fellow at the Birmingham University, the United Kingdom, to carry out his research on the analog model for aquifer characterization under Professor Ken Rushton. That work, and by using his own financial means with the support of an IRPA research grant, enabled him to complete his doctoral work on saltwater intrusion in a coastal aquifer under the supervision of Professor Emeritus Sohadi Bardai. He focused his work then on the transport processes in the environment, and since 1988 has presented 2 keynote presentations and published more than 100 papers, edited 3 books, translated 1, and wrote a book entitled Environmental Pollution, Assessment and Management. He was awarded the IEM Tan Sri Yusof Best Technical Paper in the year 2000 and was made a Fellow of IEM, Fellow of Technological Association of Malaysia, TAM, and a Fellow of the Malaysian Scientific Association, MSA. In 2001, he was made the Professor of Civil Engineering, accumulating enough professional experience, scholarly work, and contribution to society at large.
He doesn't talk very much, but in terms of his competency and knowledge in the field of civil and environmental engineering, he would be deemed as one of the experts in this area in the country. And I like to work with Prof. Ruslan in terms of getting second opinion, because he is a very meticulous person. When he looks at your work, then he would always be able to make recommendations to improve your work. He is capable of looking beyond what the normal eyes can see, and based on his comments, you would always be able to improve your work. And I think that is one of his strongest points that we can say about Prof. Ruslan.
He had invented a pre-treatment plant for treating oil and grease from food courts in shopping complexes and discovered the Alloy S, a new material for marine boat propellers. Dr. Ruslan, together with Mervyn, were responsible for the design of the biggest sequencing batch reactor, SBR sewage treatment plant in Jelutong, Penang, Malaysia, for the 2003 to 2007 period. Professor Ruslan was elected 5 times of 2-year terms as the Vice President of the Institution of Engineers, IEM.
There are very few Malays in the Council of Institution of Engineers. At the moment, there's about only 1/3 of the council members are Bumiputra. And Professor Dr. Ruslan is one of these few who made up the Malay or Bumiputra section of the council. And he's been very active. He had given his time to be serving in various committees before he got elected to the council. And even when he was in the council, it is not easy to actually continue to be in the council, and more than that, to be standing for higher positions. He is now a vice president of the institution. And again, as I said, there are not that many academics in engineering who are active in the institution, particularly the Bumiputra academics.
From 2003 to 2007, Dr. Ruslan was the president of the Technological Association of Malaysia, TAM, which was established in 1946. He was also appointed as the member of the Board of Engineers Malaysia for the maximum term of 5 years from 2004 to 2009.
Now, I do know that Professor Ruslan is also in the environmental field, and in that field, it is certainly a multidiscipline field. And therefore, the ability to work with people from other disciplines is very important. So Professor Ruslan has this advantage of being a Bumiputra engineer, but actually being active in an institution where there are many non-Bumiputras in engineering, but also in this case of CONSTEM to be in the company of scientists and technologists of multi-races and multiple backgrounds. But being able to spend time outside the university and to be recognized for what he can contribute, it is certainly something for UiTM to be proud of.
He is also presently a member of the Board of Quantity Surveyors Malaysia, BQSM, and a member of the trustees of the Construction Research Institute Malaysia, CREAM. As of July 2010, Professor Ruslan was elected by the 33 member associations of the Confederation of Scientific and Technological Associations in Malaysia as their 4th president in the 25 years of its existence.
He has been a council member of COSTEM for many years, and therefore he knows what COSTEM does. He has been the past president, or not yet. He is a council member of Institute of Engineers. I think he's now the vice president. So he has also had long interaction with the Institute of Engineers, and therefore he knows the importance of cooperation among the different scientists. So he has sufficient experience, and I think he can lead COSTEM. 30 years ago, we felt that we needed an umbrella organization where the different scientific associations can meet and discuss areas of common interest, how to cooperate with each other, how to interact. And this led to the formation of COSTEM. I think in the beginning there were about 10 associations who are the founders of COSTEM. They joined together, formed the association. Since then, the membership of COSTEM has grown. Today we have 33 professional associations who are members of COSTEM. Together, they will represent something like 100,000 scientists. The big ones are the Malaysian Medical Association, the Institution of Engineers, the Institute of Chemistry, but there are many smaller ones with membership of a few hundred to a few thousand.
Professor Ruslan is also currently heading the research on green and reverse logistics, supported by the Ministry of Higher Education, MOHE, and is still continuing his research on river rehabilitation for river basin sustainability. In conclusion, we have here the Professor of the Day, who has contributed and continues to do so despite being the unsung hero.
Assalamualaikum, selamat pagi tuan-tuan dan puan-puan. Terima kasih kerana dapat menghadiri pembentangan syarahan saya ini. Dan saya berterima kasih juga kepada pihak-pihak yang telah bekerjasama menjalankan persiapan untuk syarahan utama saya ini. Ini merupakan satu big moment for me, and I wish to continue my presentation this morning in English. When I was told I was supposed to give a professorial lecture, I thought of giving a topic that is really my own in-depth studies, which is the transport processes. But then when I talked with my friends, they were telling me nobody would come to that lecture. I wish I could deliver the lecture, and probably the only one that is present will be my wife. She's always there all the time, so So that is something that I've changed a bit in order to capture the essence of what I have done over the last 30 years. So this day is also a big moment for me because this date marked my 30 years of my working experience. I wish also to acknowledge some of my mentors, my supervisor for my Ph.D. work, which is Dr. Zuhadir Bardai. He's now the UNICEF director in the board of directors. And also the late Professor Harun Ismail, our faculty member. He was also one of my mentors. His saying was, the most common of his saying was that, jangan serius sangat. And he was saying that if I go into any elections, don't worry. The only thing that you could lose is you're not going to be dead, you only lose. The worst thing to happen is that you just lose. So I went into the elections in my IEM, in COSTEM, and in various associations. I think sometime there, I was like in 5 or 6 associations. And I lost all the times and also win all the time. I won some of those and I lost some of those. These are the paths of life, which I think everybody, the younger set of members of this faculty and many others would be like to experience as they go through that on their life and their career. Now, Driscoll was one of the university professors in Syracuse. He was also one of my mentors. He was a very distinguished professor. He taught me the details in environmental engineering. Still is around, he's still around. Professor Friedman was my advisor, my thesis advisor. When I came back from US, he was saying that I would be the leader in environmental engineering 50 years from 1984 in this region. So now I'm still 30 years, so I've got 20 years to go before somebody catch up with me. Right. All right, in discoveries, in this journey of discoveries, I always talk to my students, you need to discover new things, not only new things, but to discover oneself. On this journey is what we're going to do today. Let's go on the lighter mode of looking at the smaller or the lighter event of the day rather than go to the serious parts. Let's look at the incidents like this in somebody's lifetime. You see a car there that is supposed to be things blocked. There's a car that is down there, submerged and drowned, as if they need help. It needs help. So we have this lorry picking it up, and then of course that would survive on the day, right? So we're managing to leave it up there. And what happened to the lorry? So it went down. Never mind. People are scratching their head. What happened now? We call another help. So this bigger lorry, John Long, probably were able to leave it up. That's done for a smaller lorry, smaller vehicle. Let's see what happened to the big lorry, the bigger vehicle. Lorry also went down. Right? Never mind, another help on its way. So, in our lives, we need something like that, some uplifting of the spirits. So I lost my parents, but I need this sort of lecture to lift my spirit up. Thanks so much. Right, what I'm going to deliver today is the easy part. The ecological footprint, the sustainable approaches in buildings, in basin management, and also in transportation. And lastly, and most importantly, on ethics and sustainability, where I would like to link this to why we fail up to this point in handling the issues of environmental concerns. Right, sustainable development is semantically what it means here. It could refer to the necessity of to live sustainably, to the process of getting there, to the current sustainable lifestyle, or strategies to solve a crisis. So I picked a title of Green Engineering to show the partial sustainability, the process we are going there. Not reached yet, but this process of getting there. Let's look why it is a concern for us to consider that. Studies by Wegermel and his team showed that in the year 2010, and below that, and before that too, we are using 1.2 the resources of the earth, 1.2 times the resources of the earth. It's not sustaining. So if we go as business as usual, you're talking about that. We are going to go on the serious case of losing this altogether, this earth. So in 1999, that was about 10 years ago, humans were using 120% of the natural resources of the earth, and that's not good. So the whole challenge of sustainability is to find a way in our processes, in our jobs, in our production lines, can we return back the ones that we have used? That is the key into that. So that is the stresses, there's the stress being made on sustainability. So get that picture so that you can understand the rest. It's simple as that. So all the time I'll be going on sustainability with this respect, on this aspect. Right. We compare the more developed regions and the less developed regions. You notice that the less developed regions are actually on the rise together with the more developed regions. They are more or less horizontal here, but the world itself, combination of that, you notice a rise in terms of population. So that is something that engineers, or for that matter, any technologists would like to think about. It's the world at night. We notice, therefore, where are in the parts of the world people are populating, which are the concentrations, basically there, in this region, right? So where is Malaysia? Somewhere there, right? Somewhere there, okay? So they are not so hardworking at night, I guess, right? But then look at the time zones are there. Now look at the recorded carbon dioxide emissions, right? They are on the rise in terms of carbon emissions. Plenty to worry about. This actually coinciding with the Industrial Revolution, which I will explain in a minute. All right, we got a term called ecological footprint. In order to keep track of our direction with respect to sustainability, with respect to regenerating, with respect to returning back the sources, so we're looking at ecological footprint. Ecological footprint was actually driven or thought of by a Ph.D. candidate, Ph.D. graduate in British Columbia. He came up with this term, and that is now pretty much used in most planning. So we look at the available ecological capacity, the ability of the land to support that population, and the ability of that land to receive the waste from that activity. So that's how we look at. So the challenge, therefore, can we save the forest while using the trees? I'm not so-called environmentalist. I'm more pragmatic. I'm more of getting the developments done, but at a sustained rate, at the rate where we can be sustainable. Right. The first thing that I'm going to talk on is the watershed basin management. It's a large-scale thing. It's a big issue because it addresses the whole lot from surface water, groundwater, and also the point and non-point sources. So I'm going to deal a bit more on this rather than the other two topics, rather than sustainable approach in buildings, rather than sustainable approaches in transportation. All right, these are the transport processes which I was thinking of giving to the audience. So with this sort of topic, nobody would come to my lecture. But this is the underlying principle of my work, which governs, therefore, to simply put, there is a flow of the individual particulate or pollutant with respect to the flows themselves, as well as its own ability to flow in different direction or to move in different direction. That is a philosophy which I apply in most of my work, relying on whether we move with things or you have your own direction, whether you have your own journey. So it applies this sort of transport processes in the land pollution, in air pollution, in the kinetics of bacteria, in the flows of pollutants, of course. These are been applied. So in my work, I could actually expand on this. So that was the basis of my work and the underlying principle of my 30 years of work. Right. Can we see that equation just now in simplified terms? Of course, you can see it, you cannot see it because it comes from a thoughtful process. To see the equation the way that I've said just now, it came from a process. So that process requires us to think clearly through, and that is the complex on its own. And you come to the answer, this is where it is. It applies throughout. The transport processes in terms of FIEM law applies throughout. So an example here, whether the fish larvae, for example, flows based on the dominant of the convective flows, right? Do we model this without the fish being able to swim, right? We can have also another way of modeling it, which is not in this manner, but another way of telling in this case, a fish where it can swim. Also, this might be moving along with the current, with the velocity. So you can actually model this independently of the movement. So in life, the same thing too. Either we're going with the masses, or we have another direction, our own will. Similarly too, right? So in air pollution, in environmental processes, they are governed by the FIEM law. So that's the most common law, and that was my doctoral work some years back. It formed the basis of my work further on. Right, sustainability, therefore, we're looking at getting beyond environmentalism. So when I was called upon as an environmental engineer, I would like to remain as an environmental engineer, because engineers are supposed to solve problems, not a problem onto ourselves. We're supposed to solve also the correct problems, by the way. So we have the watershed. This is the overall picture of the watershed. You would notice where are the pollution that can be occurring, as well as how to mitigate, right? So we have a river flowing, and we got the point sources. We have also air pollution there. So in the basin, you have multitude of variables. This by no means difficult. These variables are really meant to be studied on its own, synthesizing it, after analyzing it, and you come to the solution. So there is the engineer's work, or anybody's work for that matter, to solve the real problem. So these are the identified sources of river pollution that form quite a number of my consultancy works and also my research work on how, therefore, to rehabilitate rivers. We are having the stage of rivers now, which basically are not nice to look at. Now we got the kinetics. So I was told also I'm the kinetic man, looking at the transport. In this case, the independence of the bacteria move along when the conditions are right for them to move. So, you know, that law still applies here. So here you can predict what will be coming out for a treatment process. Here, what is going to come out, the number of cells that will come up, how we generate cells. So we can have steady state situation where number of cells generated will be washed off or be taken off, and then we have another set of cells being generated. So in 1988, that was my first paper in the conference, using computers to generate, to find out the energy involved in terms of acceptor and electron donor. was supposed to be solved through a Fortran then. We used Fortran those days to solve this. One of my recent work was on pre-treatment. So I have a smaller sort of plan utilizing those principles. And we have a lab as well as the installation of that in one of the complexes, shopping complexes. So this works. We have the result that show it work. Over the first month, second month, and the third month, it was monitored every day without fail. And in the 3 months' time, it took to be a steady state. And that is working even today. Right, another plant, a bigger plant, there is sequencing batch reactor. That is the biggest STP in Malaysia. So Mervyn and I, Mervyn Gorowski, we actually have put up the cases or the design of that, and it came up in the form of this SBR. This is how it works. Simply as the cutoff on that work. So these are the inlet works, the preliminary treatment, and it goes about to the physical treatment. Normally, when it's a preliminary treatment, talking about the physical treatment, then it will be the water that comes out of it will then, or the liquid that comes out of it, will be therefore be put up in the various tanks. This is so-called, this is still under preliminary. It goes under the tanks later. So you have the biological treatment where the tanks are supposed to reduce. So it was designed for 1.2 million population equivalent at a cost of 450 million. So the idea then was to make waters good enough to up to the tertiary level. The biological nutrient removables were designed, and it was really, in a way, been done to achieve those intended design criteria of the effluent. These are, again, the tank. So in one tank, in the SBR, you got in one tank. So it is time dependent, goes in, aerate it, settle, and take it out in one tank. That is SBR. So this is the one that go into the next unit. That will be the pre-thickening. That will be thickened out, will thicken so that it can increase the dry or the solid weight, the solids content of it. And so that is pre-thickening in the tank. So it settle, it will be thickened, and it will be by gravity compacted, and it goes to the slush holding tank. And that, by the way, will be therefore, we have the slush, and that slush will be further undergoing slush treatment until you get sometime like 20% of solids. And then we're proceeding from there to the approved landfills. Right? This is the thickening process still, right? And it goes about from here to the, we got separation between the liquids and the solids here, and then it moves to the next unit. And it undergoes various so-called treatment after that. One is the slush digester. Now, with the interest in terms of global warming, the decrease in terms of carbon, and so on, there's a carbon credit arrangement where by using this, we can actually have this carbon trading being carried out. So that is after I've left, somebody took over the job and continued after that. So that was the biggest plant, and so I have actually done a bit on from the smallest plant to the biggest STP. And the STP is in Julutong, and that is supposed to be now the proving period then showed the influence, and from this basin 1, 2, and 3, and 4, you see the effluent are quite all right now. So it served the design, the intended design. Right. Now, the other aspect of the basin problem is the non-point sources of pollution, the solid at the sediments. The sediments will be ending up from the rivers, from the upstream, ending to the sea. This picture was taken from the aircraft. You could see the river was at the estuary. It is covered with sediments, right? And it is not a nice view to look at, right? In Portland studies, we look at the mangroves. The mangroves played their role in terms of the protection of the beaches. And what happens if we don't have any mitigation measures to hold on the sediments from upstream? What's going to happen will be these mangroves will therefore be devoid of the function of it to protect the fishes. So if you remove the mangroves, not only you don't allow the fishes to be foraging and develop or then multiply over there, but you actually also, the sediments, if they're not being protected against the planktons who are able to serve as the food for the fish. So if you remove the planktons, because then it's been engulfed by the sediments, you will find that it will be gone, and absence of plankton, therefore, absence of fish. So they've been engulfed by the sediments, and they'll be captured by the sediment, and it goes downstream. So removal of mangroves, it may not serve the purpose of sustaining. Removing the mangroves will actually show us, will actually indicate the way to unsustainability. Right, in terms of the erosion itself, is famously done using the Russell equation into predicting. So we have here root zone. I look at in the lab in terms of shear strength, the ability of the roots to hold on to the kind of covers they're supposed to do. If you look at the previous equation, this is A is multiply of this. So if you got any of this being reduced, you are talking about reduction of the soil erosion. So if you put the covers on, it will reduce the erosion, right? So what we do now is to cover them up with the various covers, right? So the samples previously were taken from this particular site, from Sungai Jendram. The Sungai Jendram sample were taken from the lab, and then the various were actually improved. These rivers were then improved. This is previously, now it is there. And we actually covered up with a mat to protect that and allow it to grow to this sort of length of the grasses. Right, now we have the auditors of the project. We got to test the ability to see whether the slopes now are safe, right? So auditors will come on board, and they're actually a bit frightened to go to our covered river banks. Right? This guy was actually looking around whether it's safe or not. So he went there and, oh, it's okay. So we passed the test with flying colors. So the sample was taken in the lab and showed that the strengths are there in terms of strengthening the river banks. Right. Another of my work is at the end of the estuary, meeting the sea. We have the ports, and the ports are supposed to be marine boats, and they got the propellers. I've got here in my presentation some of the propellers, which the failed ones, right? And this is myself. This is Dr. Darius. Now we were supposed to go about getting the research for the university, so we went about, right? So these are the two dockyard managers, right? So we're looking at the failed propellers, right? We did the towing test of the boats, and these were the results. And we found that there's a new alloy that could be from this combination of copper, nickel, ferrous, and manganese of this portion, and they have better mechanical properties compared to the other two alloys. So that was the finding. And we also have we are also protecting the cages by having, we are also protecting the impellers by having the cage. And the cage 4 was found to be, this is a cage 4, is a better resistant effect of about 20%. And we can prevent the waste from hitting the propellers, while at the same time not putting too much penalty on the boat speed. So that is the findings, and they were then taken up by the port authorities. Right. If we look at the basin again, I spend a bit more time here because this is essentially a big scope in terms of the basin itself. Now we need, therefore, to solve this basin management problem, you need to have a combination of teams. We need the people from other departments looking at these issues. For example, if it is in the LUAS is a Lembaga Urusan Air Selangor. So they need to actually liaise with DOE, Land Office, and Land Office too will interact with from the state of Selangor with local authority, and the town and country planning with environment and drainage with the district DI. These are all a team's approach. In our approach of solving the solution now, it requires us to have a team approach. No way the engineers can be just whole person or they just being the sole authority. You need to work with planners, with the policy makers as well. Now, one of my proposals to solve the basin is to have this setting the stream standards, the total maximum daily limits, which we set the standards so that people cannot be allowed to discharge beyond that. If they do, they need to pay penalty. Whoever are doing better or do some kind of best management practices upstream, they got to be compensated. So this is the Clean Water Initiative, and also the public communication. We need this involvement of the public. So many times we said about the failures. Why? Because the rakyat or the people are only relying on the government to solve this problem. They cannot claim ownership. So I was proposing then for any of these rivers, when they become better, you should publish that, so that the people or the citizen would know the improvements that have been done. So that in a way they can claim, oh, they also are the players. They can also own that sort of effort. Right. One of my rehabilitation work here for the 6 rivers, I should just show you just one. Right. We do a modeling of the rivers. When we do modeling of rivers, we'll find out where is the areas that we can reduce in terms of this trash river to 2.8 kilometers from zero from the sea to there. So we can find out how much to reduce by looking at the measures in terms of both structural and non-structural measures. Right, we can do also looking at the DO, the modeling done to look at the patterns of DO, especially so near the estuary. You got a complicated way of modeling DO or the dissolved oxygen at the estuary because of the changes in terms of the water quality there. Another one is the tidal. When you are working at the tidal effect, these are fairly complicated. It takes many more of computer time to find a solution. Now on the river basin, and this is the aquifer charging to the river. The saline intrusion will be a problem in rivers, in the groundwater, right? So this is the work done. So you notice from the high chloride level and go down to a bit 8 kilometers from the source, from the river, from the sea. This is the migration of chloride. So in the saline intrusion work, we can actually model the whole stretch of the aquifer to find out where actually the limit of where you can pump water. All right? So in this case, you got 0 to 7 kilometers. From the sea, you got that. Right? So you can see that the chloride level is pretty much lower and lower as you go upstream or you go inland, further inland. But if the whole basin is pumping, like in this case, the water is being used for drinking, so they keep on pumping, it will come to the stage where the saline intrusion will be entering their intake point, and that finishes off that plant. The treatment plant, the treatment plant is relying solely on the groundwater source. Right. The current linear urban water system is what is persisting now. So what I'm proposing is something like closing the loop, make it sustainable. It's not yet that. By talking about water reuse, you're talking about stormwater utilization, you're talking about the whole stretch of the basin management. It covers the whole stretch of the point and non-point sources management. So we come to the point of where is the solution. We have done about a lot on environment. Where is the economics of it? So we need to find a point where E is the meeting point. There is a solution, yes, but is it affordable? There's a damage yet, is it acceptable? So you got to find a point in any of these basins, what will be the basis of the mitigation measures to reach this point E? So that is the proposal. And here is the way we work out in detail. So you find therefore at its minimum cost, this is therefore affordable. And therefore also the damage is the least. So that's the point you should adapt in terms of solving basin management or basin sustainability. Right. So that is on basin. Now, this is a sample of the work which is involving the rehabilitation of a river, in this case, Pringgi River. So you can see here both the structural measures, mainly here. What I believe would be a combination of the human aspect as well. People need to come in and help out. People need to come also be the ownership of these rivers, which is not happening yet. We have the structural measures into improving the rivers. The engineers can come up with a solution. I have in my book also some of the solutions that we have found, but as long as the people are not there, we fail. We can meet the economics part of it, but it's not sustainable. Because lose the point of that people participation, and that's not happening. And therefore, I said, I always say that sustainability is a way when we go up there, it's not there yet. So it's a way, it's a long way, it's a long journey to make all this sustainable. These are the rivers. You notice most of the rivers in Penang, it basically no more rivers, they're like drains now, concrete drains. And we can actually trap the pollutants coming into the rivers. These are called gross pollutant trap, again, structural measures. We can build up the turbulence by having these rubber dams. The turbulence will create that DO, and there will be a mix of the air coming in and also this turbulence, so you got a better in terms of, you got a better DO. For a fish to survive, you need something like 4 milligrams per liter of oxygen. So you need to maintain that. So we can have structural measures like this. And for point sources control, we can have the membrane bioreactor. You see that was done through membrane bioreactor. You notice water is better. Now this is a further improvement, creating that turbulence. By having this turbulence, you actually improve the quality of rivers. Right. We can always use erosion control blankets to protect the slopes, as I mentioned just now. And we can have the proposed landscaping, make it aesthetically good looking, to be able to appreciate, for people to appreciate. So for people to actually maintain, and they would like to see this. This is an artistic view. It will never happen, I guess, in real terms. But we are going there in terms of finding, or in terms of reaching this level, where people will love the rivers, because they look this aesthetic, good looking. Right. This is the proposed landscape for this river, and that is therefore a place where people can walk through and appreciate the rivers. So that is another view of that river, right? Right. I look at now another important issue in terms of sustainability approach in buildings, how we design buildings. So the features of the buildings, are they sustainable? It's another issue where a lot of people are a bit concerned about. There are ways now to improve buildings. Are they now at what stage? What are the stage they are now, right? We have the principle of engineering, or called the green building principles, green engineering in buildings. The first principle is therefore economy of resources, right? Use of non-renewable is actually minimized so that we can have the buildings that after serving its useful life will be used for other buildings as well, the components of other buildings. And in terms of water reuse, why not we can use rainwater? Rainwater is done here through the JPS HQ, right? This is a system of rainwater is commonly used in kampung places, in many kampung. Not a problem in utilizing that. Now, this is my workers and we come up with this chart that can be used to actually design the tanks that can conserve the sizes that can be conserved. You notice, therefore, at this point and that point, you can calculate what will be the size of the roof required for a certain number of tanks you want. So the number of demands you want, can go back to design the size of roof you want. This is an important finding, and that can be used because these are the two variables, the roof tanks as well the roof as well the tanks at the bottom or at the ground level. So these two needs to be found in terms of their sizes. Another finding is the optimal sizes of roof that you can do. This is my chart that can be used in regions like the north, the south, and the middle. So this chart, you can find out there's no point in building or in constructing bigger roofs than the optimal roof sizing, because the rains will never be caught. So that's this finding is all about. Right. The other one is life cycle. Principle 2 is the life cycle, and it's a big component of the design. So that will be during the pre-building, the building, and post-building. So in the design of buildings, what will be the emission in terms of solid, liquid, and the gaseous component to the atmosphere? We address them there, and we solve it. We minimize the damage. Right. Now we come to the concept of building green. It is building green by having a building that is covered with plants, with trees. They look green, yes, but they're not green in the sense that we want it to be. Green building here means constructed completely with environmentally friendly materials, operate without adverse environmental impact, would rely completely on renewable energy sources for its energy requirements, and when its useful life is over, will be deconstructed. So the loop is there. Pre-building stage, operation stage, and when the building or when the operation is over, we can deconstruct it. So that is what sustain is all about. To sustain that way. Nothing is going to be returned, nothing is going to be taken from the earth without retaining them back, without returning them back. So in this century of design, we're talking about end-of-life matters. The first 19th century and 20th century are the efficient and the maintenance that matter. Now it's the end of life. Can we design the buildings for the whole lifetime of that building? What happened during those 50 years? Are they comfortable to stay in that building for 50 years? Are those buildings homes or not? Or simply a house? So there's a difference between a house and a home. A home is something that you long. There's something that belongs to you, that you have a sense of belonging. A house is simply something that you may not be to your liking to be there. Do you go house or do you go home? So you go home where the loves are there. Right? So in terms of the end-of-life design, what we're looking at the efficient design. So therefore, we can really be using the materials that can be competitively priced with the rest. So stainless steel, one example of this, with efficient design, you can do better in terms of being competitive. So in choosing structural systems, therefore, you look at the flexibility of plan. You look at, can your building be adapted for alternative layouts? In the structure system, are they economical? Does it utilize local expertise? How does the system help with the natural lighting? These are all the questions that structural engineers have to answer. And in terms of material choice, what happens at the end of the life of the materials? What is the source for the materials? Do the materials contribute to the other design goals, as thermal mass and so on? Now, what do you think will fit the bill? What do you think a building that will fit the bill of these two? None other than our kampung house. Kampung house fits this theme. You have here openable windows at our body length. We have ventilation out there and ventilation down there, right? 3 routes or paths where ventilation can take place. You have the thermal mass, or using low thermal capacity materials as the construction method. And you have here the roof, helps to cool the house. They do not need any air conditioning there. So it fits the bill of the two I mentioned just now. The technologies that we have in the kampungs are actually appropriate for our climate. And you notice too, why should we separate from exterior and the interior? We don't have snows, hopefully not. We don't have extreme conditions outside. So there must be therefore an intimate contact between the external and the internal. This is something that we need to design our building, to have this. So instead of separating out, you should have this in terms of the intimate context that can be made. In terms of human design, the third principle, which is a very important one. I said we fail in our basin management because of this aspect of human design, human participation. And we look at, therefore, in buildings too, are we failing also in that respect? If we don't take care of this, we are going to fail, right? So we have done for 23 in this case, just to show you on this graph, the human dimensions in aspects of buildings. And this, by the way, when it was carried out, everybody get confused. I tried to push this beyond the normal engineering application. The human dimension aspects are not covered in the LEED, in the rating system. I put this as an effort to actually be really in the sustainability mode, you know. So we have here, look at the quantifying the aspects of social elements, the human dimensions element. We essay that into numbers, then we accumulate the numbers, and we got this rating. Give some kind of subjective description, let it quantify, and then we sum them up. We get to some patterns of looking at how, therefore, human dimensions are taken care in buildings. Sometimes you go to the building, they are meant to frighten you off. For example, courthouse. They have a team up to frighten any of the bad hats, because you must be frightened of the courts. So the courthouse are very forcing. Some buildings are meant to actually make it very friendly. You want to go into that building. These are human aspects. You got safety, you got comfort, you got friendliness around. You wish each other. These are elements not addressed in terms of the rating we have. So we are carried away with our engineering application. So in this manner, I would try to improve the rating system by modifying the LEED. LEED, by the way, is commonly known as Leadership in Energy and Environmental Design. So I would put these values in to improve the rating systems. Up till this point, this is missing. So putting all this together, I have a way of putting this into the elements of the eco-efficiency buildings, putting the water side on rainwater harvesting side, putting on the site sustainability side. So I have here the buildings which incorporate site sustainability rating, or the points for site sustainability. So we have here the use of the sediment, the riprap, maintaining or reducing the kinetic energy as it flows down. And you got diversion channel liner. And you have here the culvert outlet, and here to protect the slope, sediment barriers, so it won't go down there. So these slopes are taken care, and they are meant to protect the sediments from going into the areas downstream. Now, as the building is going up, we can utilize the roof here to cool the building by having rooftop gardens. Got drainage layer here, you got the plant, and the soil mix plus the plant, and therefore here we install rainwater harvesting system in the buildings. It's meant for flushing of toilets. There's no body contact allowed. So you have this flushing of toilets. And the landscaping here address the runoff problem, where the areas, the covers or the parking lots are all been permeable so that water can seep through. And this particular, the water tank or retention pond will act to mitigate against flood as well over the long-term use of this particular structure, the retention pond. Instead of controlling the sediments, it can also be used for long-term arrangement, a long-term solution of flood mitigation. Right. The next one is on approaches in transportation. We are sustainable in our approaches to transportation. I mentioned at the very beginning, my underlying principle of this work is the transport processes. So what is more appropriate than to have this transport study taken up and to put up my theories whether it can work, whether we can actually approach sustainability in terms of transportation. So it still works, the principles still work, but the applications now are varied. Now, if we look at transportation, it's something that is beyond us. Something in the news are not to our liking. But when we talk about sustainability or the green engineering, the lorry drivers won't understand that. When we talk to the operators, they will understand monetary terms. So the discussion then was on how to gain, or obtain economic returns by being sustainable. So that's the challenge for this study. Therefore, we only pass through the two components of sustainability, which is the economics and the environment. But we are not yet that in terms of people aspect too. Look at this transport. We paid the toll and then we are ending up here in the open park, open car park spaces. We spend a lot of time there, and so a lot of time being wasted on the road. On the road in terms of traveling to and fro from work, to and fro in our leisure trips, we spend a lot of time on the road. So we also at the same time emit N2O or NO2 here. One of them is NO2. So the emission here will therefore be contributing to the unsustainability of the transportation system. We return to the atmosphere all these gases, and that will make up our GHG in terms of greenhouse gases. It's pretty a lot. It's quite a lot in terms of GHG contributed from the transport sector. Now, what does there in the passenger versus freight trade? A lot of focus, therefore, on passenger trips, people who are passengers or people who drive cars on their own. But the main component, which is really the freight industry, is being neglected. So by concentrating on individual travel, especially on the urban context, they have neglected freight transportation. And that is contributing a lot to congestion. Supposing you remove the lorries off the road, you are removing vehicles off the road. That will indirectly reduce accidents indirectly. That will really reduce most of the pollution that's generated from these mobile sources. The mobile sources compared to the fixed sources, they are more than 4 times. So we're talking about more of the problems incurred through transportation. And the main transportation sectors are the freight, because they're moving all the time. They don't have the on and off season, peak and off-peak season. They are there all the time. In one of the supply chain been studied, they use about 70 lorries for one consignment from the north to the south, 70 lorries a day. So we're talking about a lorry that comes down from the top to the south, from the north to the south, and then come back empty. So that's not a good deal in terms of efficiency. So when I have the discussion with the operators, especially the logistic operators, we are looking at this aspect. Can they for share? So when they see elements of economics there, that catches them, that idea catches, or they are caught with the idea. Because now there are returns. So when you talk about environment, people say that you're being too idealist. We're talking about here why sustainability is taking up very, very much now. It is because there are economic returns. By doing less, By traveling less, they make savings. And by doing so also, they reduce the emission of the gases. So we have the win, win, and win, the three wins situation. So there's something is catching up, not only, as I mentioned previously, in the basin management, as well as in the building sectors, but in transportation as well, coming up to that. Right, the CO emitted in the town, if talking about the Kota Raya, Kerinci, and the Klang bus station, this was years back. These measurements were taken over the Klang bus stand and Kampung Kerinci and Kota Raya. And you notice, therefore, the CO emission. In this case, CO monitoring over Kampung Kerinci, one of the areas of residential, quite low. But the other one, if we combine those three, if you compare them, the average daily profile for all sites is quite high. And by the way, we as Malaysians, although we are 36 in terms of GHG emission, down there we're talking about 0.9% of the world GHG emission, but per person, we are fourth in the world. We are fourth in the world per person in terms of the emission. So if you look at that, it's going to be like serious efforts needed to be done to solve this. Now, if we look at the greenhouse gases, who are the main contributors? The industry. And the industry, mind you, a combination of these transportation and industry. So 14% from the transportation. So the carbon-based fuel, this is in the contribution aspect of the GHG. Now, you look at here, what we mean by green logistics. The green logistics, we look at the whole supply chain in this case, looking at the sustainable purchases. We are looking at the distribution, manufacturing, the product recovery, the extraction and of raw materials and the sourcing. All these elements are what we term in the logistics. And the green logistics are minimizing that. Not only minimizing those travelers to travel, but looking at minimizing the emission. So this is a trend we're looking at now. Now, if we look at the emission of greenhouse gases from logistics, the road freight is something that's more than the rest. We have more compared to all the rest. So the logistics is 15% of product life cycle emissions. So logistics on road freight is the one that is contributing, and it's not easy to measure. We have the UN method of computing the emission in Malaysia, which is based on the amount of fuel that are sold in the market. There's no way of monitoring that. So our study is looking at how we can actually measure. And we are actually having that by having at the tailpipe end, the emission control and measure that throughout as it travels through the supply chain. Link that real time with the satellite moving over Peninsular Malaysia. And we have these stations all over Peninsular Malaysia capturing those at that particular point of time. So this needs to be synchronized between our group and also the meteorological group. So that will help in terms of really finding out what actually the emission. And from then on, we can build up this status quo. This is what we have now. Then we can make calibration of those models and be able to predict and therefore mitigate. So we don't notice it now, but it is something that is will be coming on, will be actually cost us huge amount of problem later on in terms of the emission contribution. Another element of the study is the reverse logistics. Reverse logistics is where the forward logistic ends. It's whereby you take the reject. Now, in this study, we look at the reverse logistic in terms of, can these returns be made use of? Can the rejects be made use of? A raw material can be, waste material can be a raw material for another industry. This is often neglected by industries. They actually pass on to anybody who can do it. They outsource the collection and disposal, but if they really take care of this, that can affect the bottom lines. That is something that we look forward for to discover from this study, and how much that. So by going over in sustainability approach in our design and our study, we are centering on the economic efficiency, by the way. And so the doctoral work of my students, two of them, are looking at the external costs and the other one is looking at reverse logistics. How, therefore, we can quantify this and therefore make this as something that when we combine this later with other disciplines, we can be a policy. Right. When we look at the green logistics, therefore, is to reduce the carbon. Carbon means the carbon dioxide. So we have here decarbonization. So the green logistics are looking at adaptive, because more so often than we cannot actually stop from the problems that are cropping up now. The problems are there in terms of global warming and so on, are part of the problem of being unsustainable. But can we actually stop? So the whole world now are talking about can we stop? But we need to, in no way, some cases we are already too late in stopping them. We need to adapt. So in terms of logistics too, we're talking about adapting to environmental change. We need to decarbonize within the supply chain. So from 1970s to here now, they come back haunting us on how to solve the freight logistics. And now we make it green, we make it sustainable. There's another scope to look at on how to improve on things. I believe we're looking at the freight sustainability model. I believe we can have the cost-effective freight transport in terms of sustainability with respect to environmental here. And then we got the societal acceptance of that, which means that we need to actually have the control, the policies for the societal aspect of it, and the financial sustainability. So a solution that reduces emission and financially viable. This is a solution we need to find out. And the shared technology, the infrastructure, the sharing, so solution for overall logistic efficiency that are accepted by the market. People are accepting that because they are good, because they are efficient. And you got the transparent freight traffic control and enforcement done by the authorities. A combination of these three segments will make a sustainability model to work with freight. So all these elements now may be a bit too ambitious now, and maybe take another 30 years to get it done, to get it going. But some elements there are already in place. I mentioned earlier on. The economic aspects are now taking in place, and therefore we reduce emission. So to make it sustainable here, we must make it attractive for people to take part. The primary data of measuring the emission from the linear source, from the Port Klang and KLIA route. These are the comparison between the models and measured, field measured, the KLIA software, the Gaussian elimination, Gaussian distribution method from 0.4 to 0.6 kilometer ranges, the contour. We can expect this is what the UN method doing now. It is actually based on how much fuel that are being sold to the market, and we compute from there. And it's another way from the US EPA method of how we can expect what will be the pollutants that will come out from the freight or from the vehicles in terms of carbon monoxide, nitrogen oxide, the carbon dioxide. These are the greenhouse gases. So we can actually compute and then compare on the field. This particular route, KLIA Port Klang route, is the heaviest so-called vehicles. The number of vehicles are the heaviest in this route in Malaysia. And there were plenty much to complain about. These are complaining about the health problem and so on, many. So these are focus our work now, and that work will actually form the supply chain. So the stretch of the world of 64 kilometers, we form the supply chain of a particular industry. And that also be repeated many, many times over the whole supply chains of the three other industries we are going at. We're looking at the automotive industry, electrical electronic industry, and also the consumer goods industry. So I believe the future will be depending on multidisciplinary approach. To be successful in our endeavor to be sustainable, we need to have a multidisciplinary approach, which means, therefore, it will be a confrontation of different scientific approaches. And together we succeed in producing a coherent picture of the relevant problem, possible explanation, and potential solution, multidisciplinary kind of work. The biggest hope here is that we are able to construct a common, comprehensive definition of the problem and explanatory view of relevant mechanism and processes and a manageable set of problem solution. We solve the correct problems. So that, in a way, is the way forward in terms of multidisciplinary. And we find ourselves, therefore, in this work, and interdisciplinary work too, right? And they are to be merged together and to be integrated as neatly as possible. And we have, for example, we can actually interfacing natural science with the behavioral science model, right? So yesterday I was at one of the keynote speakers for the Malaysian Universities Forum in transportation. So I gave a paper on the happiness index, how we combine the happiness index with actually the air pollution and solving air pollution modeling and how we put the happiness index there. Ethics and sustainability, therefore, is something that we got to look for why we fail in our humans aspect. When we compare environment and economics, normally environment will lose. So we have to look for other values. Are we convinced on the need for us to take actions? Are we convinced of that? Right? Are we convinced of that? So look at the emission of carbon dioxide. This is convincing enough. There's a flow of the increase of CO2 there. Right? And then this particular year, 2010, you see there 392 in June. The first 6 months of this year is the warmest month in the Earth has ever experienced. So you notice 392, which is fall neatly here. 392 then, neatly there. So which means that we are already too late. Most probably it's going to go on there, and you can see the results even today. Evidence of changes in terms of patterns. You have snows right in London now, as today. You got heavy snows everywhere. And you got deserts which are flooded. Deserts in Australia, they are flooded. Desert, mind you. So these are the geographical changes which I guess is already, by now, is already too late. So what we need to do, therefore, is to cope and to adapt. Is that not convincing enough for us to take any action? Let's look at the innovation required to solve this problem. We need to carry out innovation then, which is this, sustainability. Right. Now, these are the ethical theories. Can we tie this with our environmental concerns? Can we tie our ethical values with environmental concerns? That needs some thinking, some thoughts of it. So we have two ethical theories here based on minimizing the cost, maximizing the benefits. Or we believe in something that is a contract, things that we to do, contract with the Supreme Being, something that we need to do, and we are happy doing just that. So this is something we need to think about. These are two theories on the extreme, caring only on the results, and the next extreme, caring only about the actions, forget the results. These are the two extremes of ethical theories, both the Kant and also Bentham. What we need to look for, also another theory, Adam Smith theory, saying that we need to be pursuing our own interests, saying that the social welfare is best served by individuals, which means that individuals dominate. You don't care what happened to others, so you put these values into environment, it is no go. You cannot pursue our environmental concern if you have these values. What we need, the values for environmental concern, is the self-interest and regard for others conversion, the green zone. The green zone is whereby the self-interest and regard for others converge. This is appropriate for environmental concern, something that will be there if we all agree there's something to do, there's something needs to be done in that direction. In our engineering practices, in most fields too, you have this ethics as the hallmark of the profession. It is independence, asserting our independence from businesses. We are putting the public interest as as the highest priority. Not doesn't mean that we don't go into business, but then we don't go into, doesn't mean that we don't go into profits, but we don't go into the profiteering. We do that into our concern of economics, but we don't. Now, if you look at some manners we evaluate environment, if we are normal cost of doing the CBA, we discount the future consequences. So we put a value of the river now, and the 30 years, they are of no value on paper, whereas it's not. So economic instruments actually fail in addressing the question of environment. Now, also, the rich are getting all the benefits. The poorest are struggling, say it's not fair, it's not fair. People are actually benefiting from the damage done elsewhere. Pollution here, they suffer through the benefits these people will get. So that also involves different types of people in terms of their standings, in terms of the social standing, they don't actually suffer, but the poor are suffering. So we put monetary terms values there, it will not be working. It's not going to work. So economic instruments are that individuals and firms continue to pursue their self-interest, and the environment will be protected at the same time. This is what the argument is. But I would believe that it's only making a virtue of the profit motive and ethical egoism, the individualism. So if everybody is having this individualism spirit, then no way that we can be successful in our sustainability approach. These elements of humans are failing us, either in the basin management, either in the buildings management. We are actually not making any progress there. So monetary measures say nothing at all about nature's critical stock. And in short, monetary approaches are blind to critical, the ecological realities. They can't quantify them. The cause and effects are hard to come by in solving that. How are we going to cause that? So in our job, in our research now, we are trying to do just that, but it's a challenging and a tough task to get it done. We are counting the external cost of air pollution, for example. How will be the cost of pollution to the society, to the mass, in terms of effects of those GHG. So the stock of essential biophysical assets can be assessed meaningfully in the same terms, not in other terms. So we look at, therefore, at moral values, something that we been governing our ethics, our behavior. The moral values there should be the supreme, the overarching principle of being a morally good person. Then you can have ethical behaviors, that manner. Right. In these morals, values, we need to have a repelling of mischief is preferred to the acquisition of benefits. A wrong must be redressed for the sake of justice, even though there may be economic benefits in the perpetuation of the wrong. How can we up to that? Can we stand up to that? So it is something you need stronger constitution, stronger values. And for those whose benefits the environmental degradation had occurred, be charged due to them, so they also be directly responsible for the solution. So we need, therefore, to convince the moral freedom of choice. It must be inner-directed law, to really then applying that. This needs time. This needs time. But it seems that we're not going there, and things are already too late. In terms of environmental global warming, we're already too late. So what we can do now is to pray a lot, then we can have this paradigm of balance theory persist. We have here in the paradigms of the balance theory of environment, the concept of justice, moderation, harmony, preference for the better, public welfare, temperance, balance, and equilibrium. So incorporated in this concept, a deep respect for nature, and appreciation of the interconnectedness of all life, recognition of the unity of creation, and that in the Islamic beliefs is Tawhid. Tawhid means the unity, understanding that the unity of nature and unity of creation, and that concept of morality and other living systems must form the basis of any rational inquiry. But I believe that the modern science has grown during the past few centuries, forgetting this interaction. We have grown far apart. We study only a phenomenon, but forgetting the whole numbers of other phenomena. And then we generalize. So this is a solution, we say. But it's not there yet. We don't see the whole picture yet. The whole framework is not there yet. So the study of ecology needs to address the interrelationship between things, on the unicity of nature, on synthesis, and the vision of the whole within which alone the parts have meaning. So in this process of exchange, to meet the so-called needs of man, something must continuously be written to the natural cycle. To preserve the balance of life, one should always preserve that balance. And we have none other than our Quran, which says that, and the earth we have spread out, set thereon mountains firm and immovable, and produce therein all kinds of things in due balance. They're all in due balance. Any upsets, if we don't correct that, that will be a long-lasting and disrupt the whole picture, disrupt the whole framework. That's what we are doing now. That's just what we are doing now. So we have to put the personal ethics and professional ethics overlapping that so we can be successful. So in this, it is the persistent theme of the Quran that the utilization of the resources of the earth and heavens in the way of God, which means that if you are doing something for the common benefit of mankind, it's in the way of God, right? So it is also in the best interest of the individual in the long run, and cannot be construed as a personal loss or self-sacrifice by individuals. It is the real self-fulfillment worthy of his trust as the real vicegerents. We are all vicegerents on this earth. If that concept is understood, then we can convince people to be in the element of sustainability where we're missing now, because it involves more than the monetary values. It involves all this understanding of the role of man. And that is something I put forward here to achieve that equilibrium, to achieve that sustainability. So then, are we leaders or followers? How do you interpret from this? If you're a leader, you should notice who are your followers. Otherwise, at the end of that journey, you lose all your followers. And the followers too, you must know which leader you are following. Knowing fully well these sizes are too big for you, don't go and follow that journey. Don't follow his aunt in that journey, right? So you disappear. Both leaders and followers, they have roles to play. So in the scheme of things, we're all vicegerents. So that's the ethical values that I would like to stress upon. Right. Human ethical values are something that are not there yet. We have built on efficient design and technology for environment, as mentioned just now, structural, non-structural measures in building, in basin, and so on. We also have recognized economic efficiency, but we are not there in terms of human ethical values, which transcend many values, many human values, which are not there translated in terms of numbers. These are values inside, inner directed. Those are really the understanding that comes from inside, by understanding our rules. Those are the ethical values, morally guided ethical values. We should recognize, therefore, the complexity in all its forms. We should approach the creation of this vision with confidence and yet with humility. And with humility also, I submit my proposals here. In terms of being ethical, we need to be guided by our belief as our role of the rules on this earth. Been 30 years now, and still not there yet in making any of these three to be sustainable. It's a long way to go. I hope this can be taken up by others. Coming back to the saving the forest while using the trees. Where is Malaysia? Malaysia is somewhere there. And we are here in Shah Alam. And the world now, the whole world now has survived over 200 million years. And if you live to be like 70 years old, 70 divided by 200 million years, just nothing. We just come to this world and go out of this world without leaving anything behind. take that note on your way home. Think about how you can leave something behind, something that is useful, something that we can be a mark of your presence on this earth. So in summary and conclusion, I would say that there are ecological methods to actually, the ecological footprint can be used as a planning tool by monitoring the threshold of the limiting capacity, and for sustainability in water catchment, point and non-point sources of pollution, not only can be managed through structural and non-structural measures, but requiring equal partnership is lacking now. 3, for sustainability in buildings, the design principles, a modified rating system using human dimension, which I propose, can be used to modify that. And we can also have the features of the kampung be introduced, the features in the kampung house introduced in many of our buildings in the country. And number 4, right, the green and reverse logistics will help make transportation sustainable despite the complexities of socio-technical issues. And a revolution of ethics is required here, which is replacing the ethical egoism, the individualism, which is now been predominating in the market, with making sure that the individual and the societal needs are converged for the common good. That, ladies and gentlemen, I end my so-called professorial lecture, giving my views, giving, I believe, what are the points that the younger set of lecturers, scientists can take, and I propose some measures to attain this. We as a group are failing in our sustainability efforts now, but we look at failures as half success. We are there, looking at the cup, you can look at the cup with water, there can be full of water. In the cup, it can be half empty or half full. So we look at things now as half full, you are going to fill up. Have this interest and have this converging of your meanings and thought into action. Do something about it before it's too late. Dengan begitu, sebagai akhir kata saya mengucapkan terima kasih kerana memberikan perhatian. Saya rasa agak lama juga syarat ini, tapi sesuatu yang saya perlu sampaikan dari hati saya untuk dikongsi bersama. Terima kasih. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.